All right, let's go to question number 2. So for question number 2, we have 2x squared over x squared minus 1. So I'm gonna do the easy stuff. Well, I can see something already. Can you see something in the denominator? Yeah, so you've got to be automatic. Like, oh, x squared minus 1. The difference of 2 perfect square. You can see that. Okay. And then you have the well, you can do. There's nothing to cancel out, so there's no hole. Okay, there's no hole. And I think you can write down the vertical asymptotes, which is x equals to -1 and x equals to 1. So let's go ahead and find out our intercepts. So x-intercept is when you have the y equal to 0 again. Now, it doesn't matter which version you use. You can use the version on the left. You can use the version on the right. It doesn't matter because the denominator ultimately does not matter. So you have 2x squared is equal to 0. That means x is equal to 0. That means your intercept is going to be at the origin. That means you are actually going to have the origin as both the x and y intercept, right? X and y intercept. Okay. So far, so good? Yes. All right, next up, we will look at the horizontal asymptote. So we say as x goes to infinity, the f of x is going to be just 2x squared over x squared, because the -1 doesn't matter. If you can see it, you can just write down 2. Yeah, yeah. You can. If you can see it, that's even better. I would love to see it. Okay, I don't need to. I actually do not need you to show me this work. If you can see it directly, like, oh, they're the same. Boom. Get the horizontal asymptote. Lovely. And since there is a horizontal asymptote, we would not have a slant asymptote. Okay. All right, so let's go ahead and put some lines and points onto the graph. All right, so you have this kind of graph. So pretty limited information, but actually the absence of information is a hint. For example, for the left part, because there's no x-intercept, therefore we must graph at the top half. Because if you graph at the bottom half, you would have an x-intercept, right? So the absence of information is actually some information. Okay, now, so imagine if you graph it like this, that means we will have an x-intercept. But did we find an x-intercept over here? That's why it cannot be here.
Yeah.
Okay, so the absence of information is also a piece of information. And what about the right-hand side? Same deal. Okay, same deal. So so what's left right here? It's really just this. So again, the idea it should be diagonal. So so that's really what you have here. Okay, good question. How do you know that's pointing down? Now, I'm a little bit worried too. So how can I make sure that I'm on the right side of the graph? So let's just pick a point. Let's just think x equals to 1/2. So I'm wondering, should I get this point right here? Should it be a negative number? Okay, when x is equal to 0.5, should my y value be negative? So we look at the original equation. So f of 1/2 is equal to 2 times 1/2 square, and then 1/2 square minus 1. Now, we don't need to solve it. All we need to know is that whether it is positive or negative. So what you can see here is that the numerator, it's going to be positive. Well, what is 1/2 square? It's a quarter. And a quarter minus 1. So that points you to the right direction. So whenever you are skeptical, you question yourself, it's very simple. Just pick a number. Because remember that the graph is a reflection of all the function values. When in doubt, find a number, show it to yourself. Okay, when in doubt, find a number, show it to yourself. And discontinuity, it's going to be from, well, where are we disconnecting on the graph? So in this case, we don't have holes, so we're just disconnecting at the asymptotes. X equals to -1, x equals to 1. Those are the two x values where the graph got disconnected. Okay. Domain, the domain would be from -infinity to -1. Union -1 to 1. Union 1 to infinity. Okay, again, as reflected by the graph. As reflected by the graph. Now the range, it's going to be from -infinity. Now, if you look at the graph, so it seems like the highest point down there is just 0. So it seems like there's a gap between 0 and the horizontal asymptote. And that's fine. So we will say from -infinity all the way down, all the way up to 0. And then it picks up again above 2. And it works its way up. So again, from the bottom, you just look at the graph, it goes all the way up over here. And then there's nothing right here. Okay. There's nothing right here. There's nothing right here. So you just skip over. Okay. So this part, you go from the bottom to the top right here. It stops. There's nothing in this region. So this is like a little void. And then above the horizontal asymptote, it keeps on going up. So that's why it's from 2 to infinity. Yes. Because we always talk about x value. Like we scan the graph from left to right. So, and if you say y value, that could be very confusing because you can have single y value with 2 points, okay? And you can have a continuous graph without the y value in the bottom. So that's why we don't talk about y value as we talk about the discontinuity or continuity. Well, I mean, if you know your vertical asymptotes or your holes, then you would be able to interpret discontinuity because that's what it means.
Okay, so I use my vertical asymptote as my discontinuity if I don't have a hole. But if I have a hole, I use that as my discontinuity.
Or you just look at the graph. Use the graph. Don't force yourself to memorize something like, oh, I need to use vertical asymptote, or I need to use a hole. The word itself means where is it disconnected. The graph shows you where it is disconnected. Saves the memory for something else. Okay, yes?
This is more of a theoretical question, but how do we find limits if we have a slant asymptote and not horizontal?
We actually will. Now, if you have if a slant asymptote, which we'll go over that later on, so it will go all the way up. So in that case, it's just positive infinity if it goes up, negative infinity if it goes down. Yeah. I will go over one. Yeah, we'll go over one together. Yes, that's one. Yeah. Yeah. That's why I'm making this video. And I'll go over that tomorrow too. All right. So as we go to the left, the y value becomes 2. And if you go to the right, the function value or the y value would become 2. Right? If you go all the way to the right, the y value, okay, the y value, the notation tells you as x goes to infinity, the y is equal to 2. So again, these are the definitions of horizontal asymptote. Okay.